Algebra, complex numbers. Complex numbers are numbers that consist of two parts, a real part and an imaginary part. They are written in the form a plus b, where a and b are real numbers, and I is the imaginary unit, which is defined as the square root of -1. The real part, a, represents the horizontal axis of the complex plane, and the imaginary part, b, represents the vertical axis. The complex plane is a two-dimensional plane where the horizontal axis represents the real numbers, and the vertical axis represents the imaginary numbers. The addition and subtraction of complex numbers is done by adding or subtracting the real parts and imaginary parts separately. For example, a plus b, plus c plus d, equals a plus c, plus d plus di. The multiplication of complex numbers is done using the distributive property, and the fact that I squared equals -1. For example, a plus by c plus d, equals ac plus ad plus bci plus b squared equals acbd, plus ad plus bci. The absolute value, or modulus, of a complex number is the distance from the origin to the point representing the complex number on the complex plane. It is denoted by vertical bar a plus by vertical bar equals sqrt a squared plus b squared. Complex numbers have many applications in mathematics, physics, engineering, and other fields. They are used to solve equations that cannot be solved using real numbers alone, and they play a crucial role in the study of topics such as trigonometry, differential equations, and quantum mechanics. What else do I need to know? Here are some additional facts about complex numbers that you might find useful. Complex conjugate. The complex conjugate of a complex number a plus b is the complex number a b. The complex conjugate of a complex number has the same real part but opposite imaginary part. Polar form. Complex numbers can also be represented in polar form, which expresses the number as a magnitude and an angle. The magnitude is the absolute value of the complex number, and the angle is the angle that the number makes with the positive real axis. The polar form of a complex number a plus b is given by arccos theta plus I sin theta, where arc equals sqrt a squared plus b squared, and theta equals tan to the power of -1 ba. Euler's formula. Euler's formula relates the exponential function, trigonometric functions, and complex numbers. It states that E9 equals cosine x plus I sine x, where I is the imaginary unit and x is any real number. Roots of unity. The complex numbers that satisfy the equation z to the power of n equals 1, where n is a positive integer, are called the nth roots of unity. These numbers are evenly spaced around the unit circle in the complex plane and have some interesting properties in trigonometry and number theory. Complex analysis. Complex analysis is the branch of mathematics that deals with the study of complex functions, which are functions that have complex numbers as inputs and outputs. It has applications in many areas of mathematics and physics, including number theory, algebraic geometry, fluid dynamics, and quantum field theory. Explain the absolute value, or modulus. The absolute value, or modulus, of a complex number is the distance between the origin and the point representing the complex number on the complex plane. It is denoted by vertical bar z vertical bar, where z is the complex number. If the complex number is written in the form z equals a plus b, where a and b are real numbers, then the modulus of z is given by vertical bar z vertical bar equals sqrt a squared plus b squared. This formula is derived using the Pythagorean theorem, which states that in a right triangle, the square of the length of the hypotenuse, the longest side, is equal to the sum of the squares of the lengths of the other two sides. Geometrically, the absolute value of a complex number represents the length of the line segment from the origin to the point representing the complex number on the complex plane. This line segment is also known as the vector or the radius vector of the complex number. The absolute value of a complex number has many useful properties. For example, vertical bar z vertical bar caret 2 equals zz, where z is the complex conjugate of z. This means that the product of a complex number and its conjugate is equal to the square of its absolute value. Vertical bar zw vertical bar equals vertical bar z vertical bar w vertical bar, where z and w are complex numbers. This means that the absolute value of the product of two complex numbers is equal to the product of their absolute values. Vertical bar z plus w vertical bar less than equals vertical bar z vertical bar plus vertical bar w vertical bar, where z and w are complex numbers. This is known as the triangle inequality and states that the absolute value of the sum of two complex numbers is less than or equal to the sum of their absolute values. The absolute value of a complex number is a key concept in complex analysis, where it is used to define the topology of the complex plane and to study the behavior of complex functions near singular points. What are your tips to the best way to learn this? Learning complex numbers can be challenging, but with the right approach and some practice, it can also be rewarding. Here are some tips that might help you learn complex numbers more effectively. Understand the basics. Before diving into more advanced topics, make sure you have a solid understanding of the basic concepts of complex numbers, including the real and imaginary parts, complex conjugates, absolute value, and polar form. Practice solving simple problems to reinforce your understanding. Visualize complex numbers. Complex numbers are represented as points on a complex plane, so it can be helpful to visualize them geometrically. Draw diagrams to represent complex numbers and their operations, and use them to build intuition about complex numbers. Practice, practice, practice. Complex numbers require practice to master, so work through lots of problems and exercises to build your skills. Start with simple problems and gradually increase the difficulty as you become more confident. Learn from different sources. Complex numbers can be approached from different perspectives, so try learning from different sources, such as textbooks, online courses, videos, or other resources. This can help you see the same concepts from different angles and reinforce your understanding. Seek help when needed. Don't be afraid to ask for help if you get stuck on a problem or concept. Talk to your teacher, tutor, or classmates, or seek help from online forums or communities. Apply complex numbers to real-world problems. Complex numbers have many applications in science, engineering, and other fields. Try to apply what you learn to real-world problems to make the concepts more concrete and relevant. By following these tips, you can build a strong foundation in complex numbers and develop the skills needed to tackle more advanced topics. Like, comment, subscribe, to follow along for the trip.